link, go to the website. Grade 11. How's the assignment going? Has anyone started it yet? Okay. You're busy. Okay. If I were you, I would start it today because it is due on Friday. And who wants to be doing homework on Friday night? You know, so if you did half of it today, half of it tomorrow, and then like checked your answers on Friday, you'd be golden. Easy as that. But you got lots of homework right now? So perpetual homework machine. Okay, let's see how many people are on YouTube right now. Oh, just one person. Okay, 6 people here, including me, or not? Is that including me? No, 1, 2, 3, 4, 5, 6, 7 people. There's 6 people watching my screen. I see. Okay, that makes more sense. Okay. Just wondering if we should get started. Yeah, okay. I just have a really fun and exciting and happy announcement, but I'll save it for maybe halfway through class because I don't want anyone to miss it. It's very, very exciting news. So, okay. Not that exciting. Well, maybe even more exciting actually, but it's not that. It's not that. No, more exciting than that even. You'll just have to wait and see. Okay, so yeah, let's get started on what we're doing today. So what we're going to talk about today is the following thing. We are going to be adding and subtracting rational expressions. That's the topic of the day. And I'll be honest with you, it's kind of a big topic. It might take us a little while to fully get to the bottom of it. So we'll probably be sort of fumbling around with this topic, certainly for the rest of the week, and maybe into next week as well. It's a big one. But it's really cool because I really like it because it takes stuff that we learned like way back in grade 7. Like it takes a grade 7 context or a concept and places it in the context of what we're doing right now. So it's really cool. It's a very interesting topic. I find it really neat. So we are adding and subtracting rational expressions. Okay, and I'll kind of just draw a quick little sort of like a mind map of what this all looks like and how all this is related to other things. So what this does is it kind of takes these two concepts, which is adding fractions, right? Which is kind of like a grade 7, grade 8 kind of idea, you know, common denominator, that sort of thing. And it kind of, so you've got sort of this world, and then you've got rational expressions, and that's like a grade 11 thing, expressions. So it takes these two worlds, grade 11, it takes these two worlds and combines them, and you get this really interesting connection between kind of, you know, topics that you've known for a long time and these new like kind of beasts that we're learning are quite challenging to work with, right? There's a lot of rules and non-permissible values and things like that. So it takes these two ideas and puts them all into one. And I think it's Oh, you can't see the grade 11 part. I always forget that my head is in the way. I should put a little bit of piece of tape on my iPad or something like so I can see where my head would be. Anyway, so it takes these two ideas, combines them into one, and I think it's pretty neat. So let's get started. So the way this is going to be structured, the way I think that the best way that I know how to teach this is to do kind of like I guess like a review of adding, I'll say adding and subtracting fractions. So adding, subtracting fractions, but it's not going to be your typical review. We're going to take a look at it analytically. Okay, what I mean by that is that we're going to get a little more abstract. We're going to analyze this and think about what it actually means when we're adding and subtracting fractions. And basically the way I'm thinking about this is that when I teach adding and subtracting fractions to grade 7s, which I did several months ago, right? That's what I was doing in the first term. That's like the main topic in grade 7 is adding and subtracting fractions. And in a perfect world, I would teach them all of the amazing theory and everything like that explains exactly what's going on behind the scenes. And in a perfect world, they would all understand it. What I'm hoping to do today is to teach you adding and subtracting fractions and have you actually completely understand everything. So it's kind of like if you guys were in grade 7, it would be like my perfect dream, right? I'm teaching adding and subtracting fractions, and all of my students like understand the theory. I need you to understand the theory here, is what I'm trying to say. So we're going to look at adding and subtracting fractions, and then we're going to sort of relearn adding and subtracting fractions, but instead of a fraction, we're going to look at a rational expression, which we can kind of see are basically just fancy fractions. So let's suppose like we can always add fractions when they have the same denominator, right? AKA they have a common denominator, denominator. Okay, so that works because they're the same type of fraction. So for example, if I have like let's see, 3/5 plus 1/5, that would be, well, all I have to do is just add the denominators and I would get 4/5. And that's because these are like fractions. These fractions are alike. This is just like 3x plus 1x is 4x. In this case, x is 1/5, right? That's what it means. 3 of these 1/5 plus 1 of these 1/5 is the same thing as 4 of these 1/5, right? So when the denominators are the same, we have no issues. All we have to do is add the numerators. And if the denominators are not the same, we have a problem because we're no longer adding things that are alike, right? So let's see here. How do I write this? When the denominators are not the same, we have a problem. Okay, so the problem is that these fractions, the fractions are not alike. Right? They're not the same type of thing. So to give you an idea, for example, 2/7 plus 4/6, that, we don't know what that, I mean, you probably do know what that is. But, I mean, probably not off the top of your head. You can immediately see that if you were going to, solve this, you actually have to do a fair amount of arithmetic. And hopefully at this point in grade 11, you kind of just do it. And you're like, okay, yeah, I got to bring the 6 over there, the 7 over there, blah, 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 and then add it all up. But what I really want to do today is I want to talk about like what we're doing here, why we do it, and like really analyze what happens when we add fractions that have different denominators, because that's really all we're doing when we're adding rational expressions, is we're just adding fractions that have different denominators, except the denominators are like x plus 1 instead of 6 or 7. So okay, so what do we do? The solution is to find new fractions that are equivalent to the old ones, right? So equivalent means, like this word right here, equivalent, what I mean by that is same value. Okay, they have the same value. So like equivalent fractions could be like 1/2 and 3/6. They mean the same thing. Okay, so those are equivalent fractions. Okay, let me move that over here so I can scroll back. There we go. That's better. Okay, so where were we? Okay, yeah, so our solution is to find new fractions that are equivalent to the old ones, period. The new fractions must have the same denominator. And as we all know, there's a trick to this, right? There's several tricks actually. So the equivalent fractions, are found by multiplying the numerator. I'm going to write num, and denominator, I'm going to write den. The numerator and denominator by a common value. Okay, and if you ever need me to slow down, like if you're writing along with me and I'm going too fast, just shout at me either on YouTube or on Discord. Just tell me to slow down. But the equivalent fractions are found by multiplying the numerator and the denominator by a common value. So for example, right, let's say I want to write 7/16 as a different fraction. Well, I can just choose any number that I want, except 0. 0 always has that extra case. And we wouldn't want to use 1 either, because 1 wouldn't change the fraction. So let's make it just easy for ourselves. Let's do 2. Okay, so this is equal to, well, 7 times 2 is 14, and 16 times 2 is 32. So these two fractions are equivalent. And we found the second fraction by multiplying the numerator and the denominator by the same thing. That's how equivalent fractions are found, right? I mean, this is a whole other big topic, is what equivalent fractions really mean. But I'm hoping that we do have a sense of what equivalent fractions are and how we find them. So that's how we find it. So if we're going to find, let me just go back over here. So if we want to find two fractions, oops, my iPad just froze for a second. There we go. If we want to find two fractions who have the same denominator that are equivalent to others, well, that means we have to find a common denominator, a special type of common denominator. So to find our common denominator, well, we find a multiple, I should say, sorry, we find a number that is a multiple of both of, of the denominators. Okay, I should say the old denominators, Okay, so again, another example. It really helps to just have a quick example to illustrate what the heck I'm talking about. Let's say I want to add 2/3 and 1/5. Well, I have to find a multiple of 3, and I need to find another number whose multiple of 5, right? And I know that this is a review. Like I'm hoping you already know how to do this. The idea is that I'm not teaching you this, is that we're reviewing it, but we're really looking at sort of what's going on behind the scenes. So I'm looking for a multiple of both of these numbers, right? So the easy thing to do, and this is how you initially learn how to add fractions, and then you have to unlearn this. You have to sort of unlearn your first way of learning this is to multiply these numbers together. So to say, okay, well, I'm going to take this 3 over here, and I'm going to take this 5 over here, right? And this is the first way that we learn how to multiply, or sorry, we learn how to add fractions, is we just copy the denominator from the other side, right? And then we have, well, this would be 10 over 15 plus 3 over 15, and then look at that, it's beautiful. The first one is an equivalent fraction, the second one is another equivalent fraction, but now they have the same denominator, so they're compatible with each other, they're alike, so we can add them, and by adding them we just add the numerators together. We get 13 over 15, and we're done, and that's how you add fractions. However, there's a little something called the least common denominator. So what is this all about? Well, I mean, in a perfect world, you would have learned this first method, early on in grade 7. Probably that's one of the first times you would have added fractions in grade 7. Maybe you did it in grade 6, maybe you did it in grade 5 or grade 4, but most people learn about fractions in grade 7, at least how to add fractions in grade 7. And then maybe as you learn, like maybe at the end of the unit or something, maybe you learn about least common denominators, right? So what is a least common denominator? Well, so we can find many denominators that are compatible. Denominators that are compatible. Okay, what I mean by that is, like, if let's say I wanted to add like 2 quarters, or let's do 3 quarters plus 1/6. Okay, well, the first thing I could do, I could add, or I could multiply all these guys together, and I could get 18 over 24 plus 4 over 24. But I could go even bigger than that, right? Maybe my denominator could be 48, right? I could have 48, so I would have to double that. What would that be? 36 plus 8 over 48, right? Those are all equivalent, right? And they have the same denominator. I could go even bigger if I wanted. We could even go like to 360 over 480 plus 80 over 480, right? There's an infinite number of pairs of fractions who are equivalent to that first one. However, in math, we always want to be working with the smallest numbers possible, right? Like, objectively, smaller numbers are better to work with, right? I mean, when you first learn about how to add numbers, your kindergarten teacher didn't make you add like 6,392,800,000 blah blah blah, and like these crazy big numbers, right? You were adding like 3 plus 4, right? So when we're working with any types of numbers, and this isn't just like in high school, this is like everywhere, like in computer science, where you're dealing with like high-end algorithms and everything. Everybody wants small numbers to work with. Nobody likes working with big numbers. So we have this notion of finding the least common denominator, and the least common denominator is the smallest denominator that works. And sometimes that denominator is not just the product of these two denominators, right? Because I think we can all see that the least common denominator here is actually 12, right? So we could have a common denominator of 12, and if we did that, well, we would multiply the first one by 3, so this would be 9, and this next one would be, we'd multiply it by 2, so this would be 11 over 12, and that's actually how we would go about adding these, okay? So this is really like the heart of it. This is really the important part to understand, like how this works and how to find these numbers, because we're going to be doing this on a much grander scale, and if you don't get this part, then it'll be really hard to understand why we do what we do when we add rational expressions. So, are we okay up to this point? Is anyone mad at me or confused or anything, or no one's okay? So I'll trudge on forward. Okay, so how to find the LCD? How to find the LCD? Okay. So the LCD means the least common multiple. It's the least common multiple of the denominators. Okay, that's what the least common multiple, or the least common denominator is. We take a look at the denominators and we find the least common multiple. Okay, so if I were to tell you that I had let's say that we find we're looking to find the least common multiple of, let's say, 10 and 15. Okay, let's say we want to find the least common multiple of 10 and 15. Okay, like this is what it really is all about. This is about least common multiples. Okay, so this is the key component to what we're about to do, is understanding least common multiples. Okay, so let's say I want to find the LCM of 10 and 15. Okay, well, what I really want to do here is I first want to factor these numbers. Like I could make a list. I could certainly make a list of all the multiples of 10, right? I could do 10, 20, 30, 40, and then I could write all the multiples of 15. I could do 15, 30, 45, 60, and go, oh, look at that. There's a 30, there's a 30. 30 is the least common multiple. But what if you're working with like x's and stuff? You're not going to have that luxury. So this is what we're going to have to do. We are going to factor these numbers. So we have to factor these, and then you kind of get to see their fingerprint almost. You kind of get to really see what that number is made up of. Like, who is 10? Like, who are you, 10? Tell me everything about yourself. And the 10 would say, well, I've got a little bit of 2 in me, and I've got a little bit of 5. And you do the same thing with the 15. Who are you? Well, they would say, I'm a little bit of 3. I'm a little bit of 5, right? So now what you would say is, okay, with the least common multiple of 10 and 15, let's think about some of the properties of that. So this least common multiple, let's call this multiple m, okay? And let's think about the factors that m will have. So m will have, well, certainly m will have 10 and 15 as factors, right? By definition, because m is a multiple of 10 and 15. It happens to be the smallest multiple of 10 and 15. So if m has 10 and 15 as factors, m will have 2, 5, 3, and 5 as factors too. Okay? 2, 3, 5, 2, 5, 3, and 5 as factors, right? But look at this. I've given you some redundant information. I already said 5. I already said that 5 was a factor, right? It's like it's right here. So I don't have to include it twice. So that's how we find the least common multiple. Is we look at all of these factors and say, okay, I need 2 and 5, in my least common multiple. The number that I'm looking for is going to have 2 as a factor, it's going to have 5 as a factor, and then I look at the other number and say, okay, well, it's got to have 3 as a factor, and it also has to have 5 as a factor. But hold up, I already said 5. I don't need 25 as a factor. I only need 5. I don't need 5 as a factor twice. I only need 1 factor of 5. So that gives me 2, 5, and 3. So the LCM, oh, go on. Oh, my head was in the way. Classic. Yeah, my bad. Yeah, so M will have 2, 5, and 3 as factors. So the least common multiple, all right, the least common multiple of 10 and 15 is equal to 2 times 5 times 3, which is 30, okay? And that's really how least common multiples work, okay? And that's what we're going to have to be able to do with rational expressions, because we all know we can factor rational expressions, and that factoring, it's still the same word. Like factor in this case means the same thing as factor as it does when we factor a quadratic. They mean the same thing. It means to take this big thing and split it up into 2 smaller things multiplied against each other, right? We're still going to do that. So this is what we really have to understand is when we are adding fractions, finding the least common multiple of the denominators is extremely important, and it's the entire foundation of adding and subtracting rational expressions. So so I think we'll leave it there. I don't really have a whole lot more review before we jump into it, so I think tomorrow we can actually just jump right on into it and actually start adding and subtracting some rational expressions. But I did say that I had some exciting news, so just give me 1 second. Okay, 2 things. First thing, it's Goose's birthday today. She turns 3 years old. So yeah, she wasn't quite ready to turn 3. She's feeling a little old. She still is a little kitten at heart, but yeah, she turned 3 today. So very special day for Goose. Yeah, here I'm putting my earphones so she can hear it too. Yeah, so it's her birthday today, and we're having a little celebration for her. It's really nice. Also today, April 29th, is do a kickflip day. So if you have a skateboard and you're inclined to that kind of thing, I'd recommend you go out on your front sidewalk or something and try to do a kickflip for do a kickflip day. Yeah. Yeah, we'll give it a try. Yeah, and I'm not making that up about do a kickflip day. You can look it up. It really is today. So yeah, kind of a fun day. So that's all I wanted to show you for today. Just a little review on adding fractions. And I know it seems a little silly to be talking all class about a grade 7 topic, but I think that a refresher on how this stuff really works and to really understand the mechanics of it is really going to help. So yeah, I'll talk to you guys tomorrow. Take care. Oh, you have a question? Oh yeah, exit slip. Yeah, sure. Okay, good call. So the exit slip. Thank you. So the exit slip today is whose birthday is it today? Okay. Yeah. So I know it's a hard one. You might have to go back to the YouTube video and review, because I know that's a hard question to answer. But anyway, yeah, there's your exit slip. Please fill it out. It really is important that I get as accurate numbers as possible. So yeah, please take the time. I know it's annoying. I have to fill out like the equivalent of an exit slip every day. I have to tell the school like what I did every day, and I know it's a pain in the butt. It's like one more thing to do, but please do it. If you're not doing it, then it means I'm submitting inaccurate information, and then effectively the government is not getting the correct number of students. Like they're not getting good information. So let's try to make this information as accurate as possible. Yeah. So until tomorrow, I'll sign off and I'll talk to you then. Like goose. Yeah, just goose. Yeah, no special spelling. Okay. Bye bye guys.